figure I'm not trying hard enough to get work.
All right, good morning, or I guess good afternoon, everyone. Welcome to ACM offices, and welcome to everyone on the WebEx. We're gonna get started now. First of all, how many of you guys have been to the ACM offices before? Just a show of hands. Most of you. Well, for those of you, welcome back, and for those of you who haven't been here, welcome to ACM and the Institute of Hazard Prevention. My name is Patrick Fisher. I'm the product manager here for SafeGuard Profiler and SafeGuard Sentinel. The session today is called Moving from Hazop to LoPA using SafeGuard Profiler, which is why I'm here. And if that's not what you were expecting, well, at least you get free lunch out of it. So just a little bit of clarification, and we do have a number of people on the phone with us. If you have any questions as this goes on the phone, unfortunately you're muted, but if you send me a chat request with your question at the end, we will address it. And for everyone in the room here, prefer if you leave questions till the end, and just let me know what you ask, and we can always go back to any particular concepts we need to really touch on. So before I really get into this, how many of you have participated in a Hazop before? Hands up. Most of you. How many of you have facilitated a Hazop? 5 of you. That's not many. How many of you have participated in a layer protection analysis, or LoPA? How many of you have facilitated a LoPA? There we go. 2. Keep whittling it down. It's good that most of you have participated in Hazop. How'd you find it? How'd you find the whole experience? Be honest here. Interesting?
Box checked.
Box checked, okay. That's good. How many of you guys felt like the Hazop you were in was a checkbox exercise? Just one? I've been in a couple that have felt like that. Here at ACM and the Institute of Hazard Prevention, we're trying to make the world a safer place. And one of the ways we do that, we facilitate Hazops. But we often see that case where it's kind of a checkbox because we're required to do it. We pride ourselves in making Hazops better and making them valuable so they can be more than that. And one of the ways we do that is from taking them to the next stage, which really is layer of protection analysis. Again, it's good that most of you have participated in one of those before. I hope to show you how ACM does LoPAs, or how ACM's software can help you do LoPAs even better than what you've been doing in the past. So a little bit on SafeGuard Profiler. How many of you guys before the email that you got inviting you here had heard of SafeGuard Profiler before? A couple of you? How about Silcore? Same group, okay. SafeGuard Profiler is the next generation from Silcore, and what it is, it's a powerful tool used for the analysis of process safety during both the conceptual and detailed design stages. It's around risk. In particular, some of the benefits that we'll see throughout this lunch and learn, it helps reduce the engineering times and costs, optimize how many safeguards you have and the reliability of those safeguards, ultimately reducing your capital costs, reducing your maintenance costs, and simplifying contingency planning so that your operators know what to do when something goes wrong in their facility. SafeGuard Profiler is available in a few different packages. We've got the LoPA package, a SIL verification package, and an expert package. Today we're only really going to be talking about the layer of protection analysis side. It's a SIL determination step. That's what is just beyond a Hazop. We'll have a future lunch and learn on the SIL-V, and if you want more information even sooner than that, just talk to me after this session or talk to Brad. Where is Brad? I think he's just out there. Brad is our business development for software. He would be happy to set something up for you. So if we're talking about the layer of protection analysis and how we get from the Hazop, what we're going to do here, I'm going to set the stage and look at an example that hopefully most of us can relate to, which is a crude distillation unit. I'm going to walk you through what we would actually do in a Hazop. Most of you have participated, but a little bit of a reminder so that we're really setting the stage for this LoPA. I'm then going to introduce what is LoPA, what are the concepts behind it, and we're going to walk through that same Hazop with the LoPA and talk about risk visualization, which is one of the things that Profiler really specializes in to make the sessions easy to understand and clear make it clear what the importance of the session is for everyone involved. Ultimately, I'm going to show you how SafeGuard Profiler does things better than the software you may have used in the past for your LoPAs, whether that be spreadsheets or PHA Pro. Actually, that's another good question. Those of you who have participated in LoPAs, how many of you guys do you know, was it done in PHA Pro? Hands? How about SafeGuard Profiler? None. Okay, well that's good. How about Excel? How many of you done them in Excel? Any other tools? Yes.
We haven't shown SIF Pro.
SIF Pro. Of course.
We also have Thesis,
Thesis. Okay.
which I would not recommend for doing local.
Okay. Well, we'll be looking at a lot of those today to kind of compare them to what you get, especially PHA Pro in particular. So I mentioned we're going to start with this crude distillation unit. How many guys have worked in a plant, in a refinery in particular? Most of you again. So I mean, the crude unit is really, it's really the core. It's what makes the products. And it's really, you could say, kind of the most important part. So we're going to look at this crude unit. A little bit of a simplified design here. We'd be looking at the PNIDs and the Hazop. So that's what we're going to do here. And the way the crude unit works, it's a really simplified one. You have feed coming in. It's pumped through a heater to get it nice and hot, at which point it goes up the column. At the bottom here we have a reboiler, and that heats some of it up, sends it further back up, and draws some of it off as a vacuum feed for further processing. Also going up the column are various pump arounds that help you make products that you'd be familiar with: kerosene, gasoline, jet fuel. Depending on how many pump arounds they have, they can get different products out of it. And ultimately we have the overheads, the really light ends, the propanes, etc., that are going to come off at the top. So we have this nice pretty crude unit. We've spent billions of dollars building it. And what we're looking at in the Hazop is what could actually go wrong. So we got this crude unit. What's the worst thing that can happen? Anyone?
Fire explosion.
Fire explosion, that's a good one. Absolutely. It happens relatively often in industry that something goes really severely wrong with these and they blow up. What we're trying to do in the Hazop is identify that risk exists, identify what causes it, risk rank it, and identify what safeguards we have. So, one way that we can blow this place up is overpressure. So we're going to ask the team in the Hazop, all right, on this drawing that we're looking at, how can overpressure occur? Normally we're looking at very specific things like valves failing, equipment failing, operator issues, fatigue, etc. Some examples that we have here that are pretty high level, things like losing your pump around flow, can overpressure this thing. Losing your overhead draw, can overpressure it. Losing your vacuum draw. Lose temperature control in a pump around, and a line break in the reboiler. There's lots of different things that can all lead to the overpressure of this crude unit. We're trying to identify those here. Now, if I was going to walk you through a Hazop, we would actually go through each and every cause. But because we're limited time and I want to talk about LoPA, let's look at just one of them, losing pump around flow. So we said that it's going to cause overpressure. That's going to cause a fire and explosion. What is ultimately the consequence of that? There's various different impacts that can occur. Ones that we like to look at in particular: hazards to personnel, damage to the environment, economic impact, and reputation impact. They're fairly standard. Depending on what your company does, you may have more, you may have fewer, but really everything's going to fit into these types of categories. So we would be going through every cause, looking at this consequence, and then looking at each impact throughout it. Again, that would take a fair bit of time, so for now let's just look at hazards to personnel. So what happens if we blow up our crude unit? What happens to people?
They get hurt.
They do, absolutely. In particular, we want to quantify it to a certain extent here. So to do that, we usually have a risk matrix. There's two sides to this. One, we always grab the likelihood of the cause, if at all possible. In this case, we were saying losing your pump around flow. We give that a value of 1 in 10 per year. So that's the vertical columns. And then we look at what is the actual impact to the people. Yes, they get hurt, but how bad? and the different levels represent different amounts. In this case, we're blowing up a crude unit. That's a pretty big deal. We're going to look at multiple fatalities. So that's the very top line. Where these two intersect is what's known as our risk ranking. In this case, it makes an extreme risk. Red, quite high. And that makes sense. This event is pretty severe. It's pretty much one of the worst things that can happen within your refinery. So, we've identified that risk. Okay, what do we have in place to actually lower that risk? So again, looking at just losing pump around flow with hazardous personnel, we have things like alarms. Everyone's got lots of alarms. In this case, a low flow alarm. And we have a pressure safety valve, vent to the flare. These things are pretty big on crude units. And maybe we have a safety instrumented pressure trip on our heater to trip that and bring the system to a safe state. These are the type of things we would identify as being, well, what we have to prevent that overpressure. So, what does that look like? A Hazop is traditionally stored in some sort of spreadsheet, whether that be Excel or PHA Pro in this case. But here we're looking at what we just did. We have one cause leading to a single consequence, which is hazardous personnel, a single risk ranking, and we have some safeguards identified. We even in this case have a recommendation saying this SIS will trip the heater. We need to figure out what the SIL rating for that particular SIS is. Some people try to determine a SIL rating in a Hazop. That is not the place to do it. You should not be figuring out what your safety integrity level is on a safeguard in a Hazop. That can be a recommendation for later, for example, the LoPA stage or whatever you happen to do. So that was one consequence, the hazardous to personnel, but we identified four earlier. We had hazardous to personnel, economic impact, environmental impact, and reputation impact. So we're going to repeat the analysis for those four. This is still only one cause though, loss of pump around flow. If you remember, how many causes did I have?
About 4 or 5.
5, yeah. So we need to repeat all of that analysis once again for 5 causes. And this is what it gets to look like pretty quickly. Pretty soon, the amount of information we have, it's really good information there, but it's a lot, it's overwhelming. This is just for a simple case of overpressure in a simplified crude unit. You can imagine what this turns into as you analyze your whole refinery, as you look at things like high level, low level, temperature. You're looking at hundreds of pages, thousands of pages of Hazop information. Again, it's really good at that engineering stage because you're identifying risks and you're making recommendations, but afterwards it becomes quite difficult to deal with all of this information. And some of the things that a Hazop tries to do but doesn't necessarily answer, for example, where's the risk now? So we identified we have this extreme risk, and by identifying safeguards we've changed the likelihood of this overpressure, but we don't really know by how much. Hazop doesn't tell you that. So you can't get your proper risk ranking. You can estimate it, but you can't get your proper risk ranking. So, what about safeguards? So I only walked through one particular cause, but we had a different alarm for every cause. How many safeguards do we have? Is that enough? We don't really know because we don't know whether our risk is low enough. Do we have too many? We really have no idea at that point. A Hazop tends to encourage looking at one cause and one consequence at a time, so you end up with a whole lot of alarms after a Hazop, as you can see from here. And out of that, you don't even know, are you safe yet? What about this SIS safeguard? I said earlier, you can't get the safety integrity level for that SIS, so how reliable does it have to be? We don't know because we don't know how safe we are yet. How often does it need to be tested? None of that information is available from a Hazop. So to introduce, or to solve the issues with those, one of the things you can do is a layer of protection analysis. LoPA, which is what we're talking about here. The Center for Chemical Process Safety defines this as a process of evaluating the effectiveness of independent protection layers and reducing the likelihood or severity of an undesired event. Basically, we're looking at what safeguards we have and what is the risk afterwards. So, but it also answers things like, do we have enough safeguards? Do we have too many? Because The more safeguards you have, the harder the plant is to operate, the higher risk there is long term. And it's also a SIL determination method. That means out of it you can figure out your SIS safeguards, what reliability do they have to be, and how often do you have to test that. That kind of thing comes out of the layer of protection analysis. So now I'm going to walk you through that same Hazop stuff that we just did, but in LoPA form. One of the differences in layer of protection analysis is we look at the various different causes that can lead to one case. So before we split out 5 different causes, we're going to combine all those together and look at everything leading to overpressure. This does not mean that we can completely ignore that there are separate causes. We need to make sure that every safeguard we have either applies to all of the causes or each cause has enough protection that overall this multiple fatalities happens fairly rarely. But if I want to look at this kind of generally, the overpressure of the column and fire explosion is your hazardous event. And the things like health and safety are going to impacts are going to be your consequences. So generally we get this kind of setup. Lots of causes leading to one hazardous event, leading to a single consequence. Next thing we do is we put those safeguards we identified from our Hazop on here. We have different types of safeguards. There's preventative safeguards that prevent the causes from leading to the hazardous event. There's also mitigative or mitigation safeguards that prevent the hazardous event from leading to the consequence. In this particular case, the Hazop didn't identify mitigative safeguards mainly because the hazardous event was just so severe. On a lot of smaller events, you'd see more on the mitigation side. So if you're looking at leaks, or relatively minor leaks, you can have things like fire and gas detection. That's a mitigative safeguard. It prevents the hazard from turning into consequence. In this case, we identified a few different types of safeguards. We had alarms, we had our PSV, and we had the SIS. We now give each of the causes an initiating event frequency or likelihood. This is similar to what we did on the risk matrix in our Hazop, where we said 1 in 10 per year. Here we're a little bit more quantified. The point of this is to get a semi-quantitative analysis. So we use real data from your plant or industry data or some example data from the Center for Chemical Process Safety if you need to. Each individual cause gets a IEF, initiating event frequency. When we add all of our frequencies together, we get what's called a mitigated frequency, or MF. This is how often is the consequence going to happen, or what is the probability in a given year that the consequence is going to happen. What you're ultimately trying to do with your layer protection analysis is make sure that your mitigated frequency is less than your tolerable frequency, or TF. Lots of acronyms in LoPA. The tolerable frequency comes from a variety of sources. Ultimately, it's how often does society accept these particular events. You can never reduce risk to a 0 level, but you can look at, as a whole, how often can events happen before basically you have public backlash and things change. In reality, the way this works is the tolerable frequency is going to be defined on a company-by-company basis, at least if you're in North America. There are some countries in the world that specifically define tolerable frequencies, but that's not North America. What are some TFs that exist out there for everyday life? We drive every day, and we know that there's risks associated with that. The tolerable frequency currently for driving is somewhere around 1 in 10,000 per year. And we use a similar number to that for fatalities within the workplace is really there. It's fairly low, but it could be lower. Make no mistake there. The airline industry, for example, we do our LoPAs to 1 in 10,000. They're looking at 1 in a million to 1 in 10 million. So they're around 1,000 times safer than we are. There's definitely room for improvement, but your company will have a defined tolerable frequency, and that's on a per consequence basis. So we have these initiating event frequencies, and we can add them together to get a mitigated frequency, but chances are that's going to be higher than your tolerable frequency. So that's why we have these safeguards. Each safeguard has a probability of failure on demand or risk reduction. This is representing that the safeguard won't always work. Alarms may not always come in, or they may not be acted on. PSVs may not always lift, and even SIS may not always activate. There's a certain chance that when you need it, it's not going to work. And that's the reason why we have multiple layers of protection. If every safeguard worked 100% of the time, we would only be looking at one safeguard in any particular scenario. So the mitigated frequency actually ends up being the initiating event frequencies multiplied by the PFDs on each line and summed together. And we add safeguards or improve the reliability of safeguards that we have until such point as we meet this criteria, the mitigated frequency be less than or equal to the tolerable frequency. And that's the theoretical basis to what we're doing in a layer of protection analysis. Of course, that's a fairly traditional one, but we're only ever looking then at one consequence. And one of the things we have within SafeGuard Profiler is the bow tie. And it's a visualization of the layer of protection analysis that lets you do more work at once. So right now we're only looking at one consequence, but is there really any reason to only look at one consequence? We identified all the same causes, led to a bunch of different consequences through the same hazardous event lines. Hazardous personnel, we had environmental releases, economic impact, and international news. We can actually create a bow tie and analyze 4 times as many consequences at once. When a lot of people here have probably been involved in a bow tie analysis, it may be a little bit different than this, and that's because in this case we're using it as a visualization for the layer protection analysis process. There's such thing as a bow tie analysis where you start by looking at certain events and building up the cause directly from this bow tie, and it's less qualitative than what we're doing. Here we're doing all of the work of layer protection analysis, all of that math that I just showed you, just making it easy to understand. And it really is quite easy to explain to a team what's going on here. You know, we have these different causes. These are the barriers, and you can see where there might be issues. You know, if there's a line without any barriers, you should probably take a look at that. Another risk visualization that's available in SafeGuard Profiler is what we call the LoPA Graph. And this is just a visual representation of that same math that I was just showing you. What we have there, we have our actual risk level, denoted by the mitigated frequency. We have the tolerable risk level, denoted by TF, and there's a gap between those. The mitigated frequency is too high, so we show that as a risk gap. And using colors and simple words here, we explain what would you actually need your safety instrumented function to be, what reliability would you need it to be in order to reduce that risk, get the actual risk level to the tolerable risk. Simply shown using simple colors and the direct still level. Of course, there's some people in the room who want a little bit more of the numbers. The numbers people, I'm a number person. And we have all of those available within the LoPA graph as well. You know, you can look at your exact mitigated frequency. You can look at the risk reduction that's required in the PFD. Everything's still shown there, still available if you want it. Let's instead of looking at the bow tie, which I use to explain the concept because it's easy, let's look at what happens in a spreadsheet method that you guys might be more familiar with. If you've used PHA Pro or you've used Excel or even CIF Pro, you might be more familiar with something that looks kind of like this. Kind of looks a lot like a Hazop. And in this case, we're only looking at a single consequence. Very traditional in that method. There's our causes listed, and here's our safeguards or IPLs. They have PFDs to them. We have our initiating event frequencies, and it's doing all the math there. But I want to ask the questions that we asked at the end of the Hazop. Are we safe yet? I can't tell. Do we have enough safeguards? I don't know. Do we have too many safeguards? I don't know. And we have that safety instrument function. What reliability does it need to be? That's the first question that we can actually answer The numbers there and little tiny. There's a lot of information here, but not a lot of it is valuable to the people who are actually in the room doing a layer protection analysis with you. Let's compare that to a bow tie like SafeGuard Profiler would present. Here's all the same information that our Hazop was on, that none of us could read, and actually 4 times as much information as was on this example is right here in this bow tie. We have our causes, consequences, our hazardous event, and each of the alarms. We also have our simple LoPA graph information and more information there. So if I were to ask the same questions from the Hazop, actually one I want to touch on there first, do we have too many safeguards? Or are our safeguards actually good? Have we over-instrumented? I see an awful lot of alarms over here. It's awfully scattered. Basically from that Hazop, we've looked at how can I prevent every single cause? But that's not necessarily what you want to do. What that leads to is way too many alarms. If we can look at what will actually prevent this overpressure, we can replace a whole bunch of alarms with a single alarm, a high pressure alarm, without impacting our overall risk level. So if you look at these 2 examples, our risk at the top there is not changing, but we've significantly simplified our system. We've dropped 4 alarms. I'm not necessarily saying that at this point you remove those alarms from your system. You may need them for other reasons. But you now no longer have 5 high priority alarms. You're down to 1. And even if you could look at those alarms and say, let's remove 1. We've saved a few $1,000s on a transmitter, a few $1,000s on operational issues in the future, and the maintenance over 25 years life of your plant, you're looking at thousands and thousands, tens of thousands of dollars just from doing a simple analysis like that and saying, well, can we simplify this bow tie, make it easy to understand? So the next thing, are we safe enough yet? Anyone want to throw something out there from here? In this analysis, have we closed our risk gap? No, we still have a gap. It's easy to see, there's color there. So what can we do in order to reduce that? Well, we could maybe add some preventative safeguards. We could add some more, or mitigative safeguards. We could add some more other safeguards. But right now we have this SIS trip that's in there, and we're doing this really for the purpose of finding out what reliability that has to be. And SafeGuard Profiler presents you with the answer. We have a SIL2 risk gap. We need to make that SIS SIL2. A couple clicks, that's SIL2, and our risk gap is completely covered, and our LoPA analysis at this point is done. And we can see, if you want to look at more exact information, the TF is exactly meeting the MF, and ultimately all of the color is gone from this bow tie, which is a good thing. You want your bow ties to not have any risk left. Of course, with this single alarm, we've replaced a whole bunch of alarms with 1. That makes this alarm a lot more important. If you do this for your entire facility, it's good because now you have a list of just the important alarms, and you can deal with those as high priority. But you're also, in a way, exposing yourself to some extra operational risk. Because before, if a single alarm didn't work, like if the instrument failed, you would only be losing some of your risk. Now you're losing a lot more.
That single alarm has got to be independent from the initiator of the safety function.
Absolutely, yeah.
So you still need 2 transmitters.
You do. You need 1 for the SS and 1 for the alarm, but you don't need the 5 alarms you had earlier, right? So what we can do within SafeGuard Profiler is actually look at these individual safeguards and say, what's going to happen if during operation something goes wrong and I don't have that safeguard available? So it'll automatically generate what's my new risk without that safeguard. In this case, a SIL1 equivalent gap. Okay? So now we kind of have an idea of what we're looking at. We can also add in contingency plans, which will let the operator know what to do to bring that risk down to an acceptable level. So we no longer have this alarm, but maybe our contingency we can continue to run with increased operator observation of the column pressure. It's another safeguard that could work. But the thing is, that safeguard's not as reliable as your alarm. because it depends on a lot more knowledge. So what happens is your reliability is a little lower, and Profiler has automatically calculated what is my new risk. And we have a slight gap still. Because this is happening while you're operating, it's a little bit different than your design risk. You can run for short periods of time at slightly increased risk, but it needs to be a defined short period of time that's acceptable. So what we can do is we can say ahead of time, if we have a risk reduction of 5 remaining, we can run like that for maybe 24 hours. So now our contingency becomes continue to run, observe the column pressure, and make sure that that original alarm is reinstated within 24 hours. That's an acceptable amount of time to run at the slightly increased level of risk. So at the end of this, if you've done this analysis, your operator has a list of everything that can go wrong in terms of safeguarding within your facility, and what the risk is when these things go wrong, what to do, and how long you can run like that. It gives a lot more information for the people who need to be operating this, and they're no longer operating blind. So throughout this, what has SafeGuard Profiler done for you? So we took this Hazop. We had a few pages of information, and we've put it on a bow tie. This is the exact same information, but here you can't read it, here you can. We call this actually visual compression, which we say you can fit 12 pages of Hazop on a single bow tie. So what would, if you look across your plant, you're looking at only 50 to 100 bow ties, maybe for a really large facility, versus thousands of pages of information. SafeGuard Profiler also guided you through simplifying your system, reducing the number of alarms you have on this particular case, and figuring out what your SIL, safety instrumented function, reliability needed to be. You know you need a SIL 2. What I haven't really touched on today, and I mentioned earlier that this is a separate lunch and learn, Profiler can actually then help you design that SIL 2 SIS and do your verification, do your safety requirement specification, optimize your test intervals so that you don't need to test as often, all within the same project that you're looking at. So just a matter of a click away, you can look at all the information you need for that particular SIS. Compare this to a spreadsheet where you have a whole lot of information that you can't really understand, people in the room can't understand, and has no information about that safety instrumented function within it. Compare that to this nice, simple bow tie presentation that's available. You also have contingency plans. So for everything every safeguard you have that you identified in your Hazop or your layer of protection analysis, you know what the risk is without it and what you can do in place of that. So your operators have that manual and can run for your plant for the 25-year life cycle, 35-year at a much safer state. And ultimately, the coolest thing here, we started out from the Hazop with a total of 7 safeguards, a whole bunch of alarms. We took a bunch of them out and replaced them with 1. We're down to just 3. So again, if you can just remove one of them, the capital and operating costs over the lifetime of your facility will really astound you if you look at it. So, how has this actually been applied in real life? It's nice to see it here. I've been talking mostly about reducing your alarms, but you can actually do the exact same analysis with safety instrumented functions, because they are relatively expensive to put in, and they're often thrown in by the design team as, simple. We're going to need this as a safety function, let's put it in. A particular gas plant here, out of the Hazop and the design stage, there were 136 recommended safety instrumented functions that needed to be built and maintained for the life cycle. By using the bow tie analysis, that was reduced to 96. The capital cost savings, $1.6 million. The operational cost savings are orders of magnitude larger than that. And ultimately, the project schedule improved by 2 months just by using the bow tie and SafeGuard Profiler. We had a SAG-D facility. We didn't quite get to them early enough, unfortunately. They'd already built it. They were operating. they estimated that they had over 100 too many safety instrumented functions. Over 50% of the SIFs were bypassed just to operate. They had to turn off all their safety that they'd calculated before. The capital cost overspend was $4 to $5 million, and again, the operational cost of the time that they were trying to get this started up was just huge. Ultimately, they were able to reduce the number of SIFs they needed and prove that they could still run safe by changing how they operated and looking at a bow tie. Another one, an upgrader here, 74 SIFs needed according to the Hazop, the Safety Instrumented Functions. Once you went through the LoPA and actually did some analysis on the mitigated frequency versus the tolerable frequency, 53 were needed. And again, the capital cost savings on just that was $1 million, and operational cost huge for safety instrumented functions. So, how can you guys get involved in this? We have a variety of training and certification courses. The next one is May 20th to 21st. So 2 days, 8 a.m. to 4 p.m. You'll be here at the Institute of Hazard Prevention and ACM offices. There's also one available June 3rd to 5th that's by WebEx. This one, for those of you in Calgary, probably isn't an optimal time. It's 6 a.m. to 10 a.m. over 3 days in order to allow those of us who are outside the country to join in. And then if those are too soon, June 17th to 18th, there's another live software training and certification here again, 2 days, 8 a.m. to 4 p.m. If you want more information about these, you can go to safeguardprofiler.com or email Brad Castle, or just talk to him or me outside the room here, or you can always email software@acm.ca. All of this is on the brochures in front of you. Do you have any questions?
Yes, Patrick. I have
Yes.
actually 4 or 5 questions, so I didn't want to interrupt you.
All right, just stick to one for now, and I'll make sure everyone gets a chance.
You mentioned that the profiler will reduce the number of SIFs in this particular project from 100 to 60%. So I would like to know how you did that. Because normally in the Hazop, we add safeguards, don't exclude safeguards, or...
Right.
Patrick, could you repeat the question?
Yeah, absolutely, I will. So the question, stop me if I'm wrong, is how or why did we reduce safety instrumented functions instead of adding them? And the reason is, in all those cases, at this point, SIS is kind of so popular that they end up designing it into the system to start with. The vendors added in, the process engineers added in, and then we go to the Hazop, and what we're doing at that point is actually quantifying how good is our risk. So if we've got enough alarms and operating procedures to reduce that mitigated frequency to less than the tolerable frequency already, then why would we need a safety instrument function? So we can avoid it. Another way is the exact same way that I removed the alarms here. Sometimes there's multiple safety instrumented functions to prevent against one hazardous event, which is completely wrong in terms of designing safety instrumented functions. And you can ultimately remove those, because those are the cases where they tend to really interact at startup, and you need to end up bypassing everything just to get running. Is that?
Allow me to have a different opinion.
Okay.
So the first one is, I think the function of the software is to how to assess the reliability of the cell not to exclude it in the first place.
Yep.
So yes, we can save money from, rather than designing a cell 2 to cell 1 or cell 1 to cell 0, but take it all the way altogether. I'm not quite sure, because some of these functions are required by the design. So for example, if you have temperature, we need to have temperature trip anyways. You can't remove temperature and depend on nothing. So it has to be there anyways, but I think the optimization that we could do is to reduce the reliability level. The second point that you mentioned about the alarm, we don't really remove the alarms from the LoPA, we remove the alarms from the alarm management exercise when we rationalize the alarm. So I'm not sure, I'm still getting it.
Well,
How you...
I'd love to talk to you more after this session, but your philosophy is definitely one way to do it, and it really depends on what the original design was. And you're right, there's really large costs and saving just from going to a SIL 2 to a SIL 1, which is one of the ways SafeGuard Profiler can help doing the same analysis. Maybe you don't remove them, maybe you leave them in, but that all depends on how the system was designed. So, sorry, I'm going to go to another question here. Yep.
All of the safeguards that you spoke about were all preventative measures. You've got the mitigative measures,
yes,
like your fire detection and what have you. Does that work in exactly the same way? Do you use exactly the same tolerable frequency?
Yeah. Sorry, I'm going to click way back. The question there was, we've talked about the preventative safeguards on the left side of the bow tie, but we didn't really talk about mitigative except a brief mention of fire and gas earlier. And so the reason was because our example was so extreme, but ultimately, yes, mitigation safeguards end up, the math works the exact same way. The difference here is they'll often only impact some of the right-hand side cases. So fire and gas might only help with economic, for example. If someone's in the area, they're still going to get impacted. So you would see a safeguard on the right side just covering that. But ultimately, the calculation ends up being the same.
So that tolerable frequency then is actually a measure of risk as opposed to frequency, really? Measure of risk.
The two are correlated as long as the consequences are the same. In reality, there's actually a different tolerable frequency for each consequence here, and it's shown that way within the software. It's a little bit here for style, and I can show you that absolutely in the software afterwards. But you're right, in that case, your numbers for each of these would be slightly different. We have a really easy way to explain that. We actually show the LoPA graph in place of each of those texts on the right.
Great, thank you.
Yes?
Now we design all this, you build the plant and the plant is running. So how do we, from the operations side, how do we know that at any particular time we will be, the validation is all complete and we are complying with this? So does this product do that?
That's a good question. So again, I'm just going to reword that. Basically, this is great in the design stage, but once you get into operation, how do you know that this work has all been done? Is that your?
No, this has been done, it's implemented.
Yeah.
So at the time, if we don't do the real-time testing and everything, like the partial stroking and everything.
Yep.
So anytime the management says, are we safe? So we can say, okay, we are safe or not safe, how much safe we are. Does this do that?
SafeGuard Profiler is not the tool for that. It is an engineering design tool. What we have is SafeGuard Sentinel that actually does that calculation in real time. Sorry, to repeat the question for everyone on WebEx too is, does this work in real time to say what's my risk once I'm operating? That's the answer there is no. SafeGuard Sentinel, which all of you guys have a brochure for, it's the blue one, does exactly that, and that's a future lunch and learn, or if you'd like to learn about that, of course, talk to me, Brad, Tom, or even software@acm.ca email. We'd love to talk to you guys about that tool, because that's a pretty cool tool as well. Yes, Robin.
When you reduced all those alarms into a single alarm, is there an implicit assumption that the action you take upon alarm is the same, regardless of what kind of alarm? Because they were different alarms, right? Different services. So is there some kind of implicit assumption that when an alarm comes in, the action is the same regardless of which alarm?
So the question there was, basically we replaced a whole bunch of alarms that had different detection, but they also may have had different actions. And now we've replaced them with a single alarm that does it just have one action or multiple? And that's ultimately going to depend on what you're doing. The LoPA usually looks at the alarm as, it's two parts. It's not just an alarm. It's actually the alarm with operator action. But what that action is, you can define it in here in the software, but usually you're looking at your alarm manuals or something like that to say, basically, what are we going to do? The operator would normally actually have, they have to have time to react to the alarm in order for it to be a valid alarm. So they should have enough time to actually do a little bit of diagnostics. If you see the high pressure, you can look at what is your flow through each of these, what's your temperatures, etc. And that's the steps that they're going to take.
See, when we talk about alarms, right, some of the alarms you're trying to make it high priority or urgent priority. So that has to be on the safety system, or how robust has to be the alarm system? Do we have to have a panel-mounted one, or?
So the question is, when we're talking about alarms, how reliable do they need to be, and what system do they need to be in? Are they supposed to be in the safety system?
Because mostly the thing is, we are HMI, right?
Yep.
That's a DC HMI. They are not very robust kind of thing. So do you have, how do you handle that?
So what's going to change is actually the probability of failure on demand you can give to a single alarm, depending on what system it's in. Because included in that probability of failure is actually the probability that the operator doesn't see it or doesn't act on it. So that's going to change depending on your own systems within your company. And there's some guidance for how to calculate that coming out from the CCPS this year, but there's plenty of documentation available for basically figuring out what PFD do I choose for an alarm. So you may choose a higher reliability one for, or a lower PFD for something that you consider quite reliable that the operator always acts on. Okay. I'm just going to check here whether there's any questions on the WebEx. I don't have any. Okay, so more, yes.
I have a couple of questions.
Okay.
Throw them your way. Since you're talking about alarms, as you just rightly pointed out, an alarm by itself is not a full barrier. You need an operator intervention, and you need the operator to be able to do something.
Yes.
So, do you have the capability or the prompt within Safe Profiler to query about validity of barriers? And if you don't have a fully valid barrier, or you have a couple of ones that aren't fully valid, do you have any provision for combining them?
That is ultimately the job of the facilitator, really, is to say, is this alarm actually valid, and is it going to work? Unfortunately, there's no way for software to tell that, because the software doesn't know whether an alarm will actually work. So we don't prompt for that, just because it would be a continuous prompt. We do depend on the facilitator in that case, do some prompt.
And one more question: do you have the ability to handle a LARP as well as reasonably practicable? So in addition to meeting some tolerability criteria, you go beyond and say, okay, what else could I add that would bring the risk lower without undue cost?
Okay, so I'm going to actually repeat that question. The question is, do we allow you to basically get a higher safety than the tolerable frequency if it's as low as reasonably practicable? So if it's really cheap to do, can we add more safety? And of course you can. That's just going to show on this graph as going over here. Still going to remain gray because we're still safe. So you can absolutely go from 10 to the minus 5 up to 10 to the minus 6. You just put it in there, and there's a section there for your notes to put in that you added this because of a LARP, and you can do that for sure. Okay, yes?
Yeah, what happens if we have a different scenario other than overpressure? So for example, in the Hazop we cover maintainability, isolation, performance, operability. How you guys cover that in the software? So
there's going to be many different bow ties. And what's going to happen is you're just going to have a different bow tie for each hazardous event that you have. So what was your concern in particular? Which statement?
Other than overpressure,
right?
Operability issues, isolation issues.
Yeah, those all come from different causes. It works the exact same way. Your hazardous event is whatever is causing a hazard. That's not necessarily a safety hazard. It could be economic, like your case there where it's an operability issue. That just goes here as a hazardous event center, and then you list your causes and put in your safeguards that you have for those. So it's the exact same methodology we use. And at the end, you can print out a list of all of your bow ties, or you can load them into other software and look at all the different bow ties. Any other questions here? I want a little bit of time for Tom here to speak to some of the upcoming events. But if you do have any more questions, please just, I'll be here, probably standing right here. Just feel free to come forward.
Thanks, Patrick. Don't go too far, I got the microphone. Either stay here with me or there we go. All right, thank you very much for joining us. Big round of applause for Patrick. I think you did a great job. So In your brochures or in your packages, we have all sorts of information. Sorry, I'm just going to steal yours here, Marcel. So today was just focusing on how to integrate Hazop to LoPA. Would anybody be interested in the next phase of this, which is how do you actually create an SRS or look at the SIL determination? So just a show of hands, who would be interested in attending that one? Now we're getting to the technical guys, right? As a lunch and learn, yeah. If what you saw today you think would be relevant for your organization, please check with Brad. I'd like to introduce the rest of the audience here. Rest of the audience. Come on in, Brad Castle. You have to actually stand here. So.
Oh, you're going to make me stand next to you.
Yeah, say hi. So I just want to introduce the rest of the ACM team. We've got Brad Castle, Stefan Dong. Come on up here, Stefan. He's the guy behind the phone calls. Just come on up here. Benjamin. Ben's going to actually fill out some forms here for you, or actually hand them out to you. And then we've got a couple other guys, but I'm just going to leave them over there for now. We've got some great events coming up. These lunch and learns go on almost every month, sometimes a couple times a month. On May 8th, we actually have Ian Sutton coming to Calgary. And he's going to be hosting an evening with Ian Sutton talking about the state of the process safety industry and how it's not dissimilar from the aviation industry and other industries out there. So you should have received an email in the last couple days. If you're not, then you're not on our mailing list. I would certainly encourage you to check off the box that says, please send me an email. There's new laws coming into effect in July, and we want to make sure we're on the right side of the law. So if you don't check off that box, you're not going to find out about all these things. So please take the time to fill that in. And Inspire October 7th, 8th, and 9th. We've got a big event coming up in October, and it's a 3-day event, initial pre-conference session, and then 2 days of guest speakers and presentations with our customers, as well as our some keynote speakers. So thank you for coming. And Ben, if you wanted to walk through exactly what the next step is here, that'd be great.
Well, we're always looking for improvements in regards to our lunch and learn, so we're going to ask you to provide us a couple of feedback here after this session and any areas of improvement, suggestions, and even topics for next lunch and learn. Thank you once again for coming today.
And if you're on the WebEx, we'll be sending you that form afterwards for the same purpose.
Okay.
Yep. And the team is going to be around later on, so if you want to grab us on the way out, we're available.
Okay.
Thanks, Brad. Thanks for coming.
Thank you, guys.
Yep.
Can I borrow a pen?